So what we're going to do today is build on the last lesson where we introduced you to simplifying expressions to now working with variables and equations. And just like always, we'll go over the vocabulary first. Our first word is equation, and I know that you're familiar with this word, but the technical definition is that it is a mathematical sentence that has an equal sign between two expressions. And you can see that equal and equation both have the same root. The second vocabulary word for this lesson is solution. And a solution in a variable equation is the number that makes the equation a true statement. So basically the answer. And then number 3, solving an equation. That means finding all the solutions to an equation. Now, nearly all the equations that we will be looking at in this lesson will have only one solution. But the reason I kept it plural is to make you aware that there will be often times when there is more than one right answer. So let's get right into our examples. Today we have 4. Okay, one thing you're going to take a look at, which we covered a little bit when we were working with expressions, but this becomes a little bit more involved, taking verbal sentences and putting them in an equation. So basically taking the written language and translating it into math speak. Let's take a look at number 1, part A. The product of 16 and P is 96. Now I know that at first glance this looks pretty daunting. All those words, nobody really likes words or expects to have to use them in math. But if you take a look at it carefully, we can look for clue words and piece together what we have to do. The first clue word here is product. Product, you know, is the answer to a multiplication problem. So we are going to multiply 16 and P. And in algebra and pre-algebra, we write that as 16P. Now here is another clue word, is. In this sentence, the product of 16 and P is 96. Well, that means equals. 16P equals 96. Now let's take a look at part B, and we're going to take this one word at a time, look for our clues the way we did for part A. The sum of y and 12 is -4. Well, here we have the word sum. Sum, you remember, is the answer to an addition problem. So what are we adding? We're adding y and 12. Here's our word is again, equals -4. So y plus 12 equals -4. Let's take a look at part C. The quotient of h and 5 is 3. This word quotient means that we are going to be dividing. And you know that my preference is that when we write a division problem, we show it as a fraction because fractions are division problems. The quotient of h and q, so we'll put h in the numerator, h and 5. 5 in the denominator is equals 3. So h divided by 5 equals 3. And then part D. The difference of -17 and m is 11. This word difference tells us that we are subtracting. We are subtracting -17 and m, and that equals 11. Time for our second example. Let's take a look at these directions. Tell whether the given value is a solution of the equation. So what we have to do here is take the equation that we're given and substitute the number that they give us for the variable in the equation. So this first problem, x divided by -7 equals +126. And what we want to know is the answer a -18? And it is not, because I made a mistake when I was writing the problem. What I meant to say was negative 7x equals positive 126, where x has a value of negative 18. Sorry about that. But what we do here is we substitute the value of x into the equation. So instead of negative 7 times x, we will have negative 7 times negative 18. And we want to know, does that equal positive 126? I can tell you that a negative 7 times a negative 18 does equal positive 126. When we have an equal sign in the middle, both numbers on both sides are exactly the same. This checks out that yes, negative 18 is a solution for this equation. And we're going to do the same thing for this second example. 12p equals negative 132, and we have to test the number 11. So again, we will substitute. Instead of 12p, we are going to write 12 times 11 equals negative 132. 12 times 11 is 132. And then we bring down our answer. Now, at first glance, you might think that yes, 11 is a solution to this equation, but it isn't. Be careful. Look, here on the left, we have a positive 132. On the right, we have a negative. So our answer here is that no, this is not a solution to the equation. And we're going to try one more. Negative 15 equals m minus 9, and here we're being told that m equals negative 6. So again, we will rewrite our equation, but we'll substitute a negative 6 for our m. So we have negative 15 equals negative 6 minus 9. So here we get to practice our rules of integers. We'll bring down our negative 15, and here we're going to combine a negative 6 and a negative 9. Both numbers are negative, so we'll bring down the negative sign. We'll add the integers, 6 plus 9, that equals 15. Negative 15 is on both sides of the equal sign, so yes, negative 6 is a solution to this equation. Time for example 3. Word problem. Dragonflies can move at a speed of about 50 feet per second. Find the approximate time it takes for a dragonfly to travel 400 feet. Well, the first thing we want to do is set up an expression, something that we can use, a variable equation, something that we can use to find out the distance, no matter how many seconds a dragonfly flies. So what do we know? We know that it flies 50 feet in a second. So that means we're going to call that 50s, 50 feet per second. And what we're doing here is we are going to find out how long it takes to travel 400 feet. 50 times s equals 400, and I know that you can do that in your head. 50 times 8, 50 times 8 is the answer. Pardon me, I'm sorry. So that means that the dragonfly can fly 8 feet in 400 seconds. I'm sorry. So the time it takes is 8 seconds. So a dragonfly can fly 400 feet in 8 seconds. one more example. Okay, up until this point, we've been doing a lot of problems with area. Today we are looking at the perimeter of this irregularly shaped figure. So the perimeter of this figure is 42 centimeters. What is the length of side X? So we will be looking for this. Now we know that when we are finding the perimeter of an object, we're looking at the distance around the object. Peri comes from a Latin word that means around, and meter means measure. So we're looking for the distance around this figure. And the formula for finding the perimeter of a figure is simply just to add up both sides. So our initial equation is going to be that our perimeter is 7 centimeters plus 12 centimeters plus 5 centimeters plus 8 centimeters, and then finally plus X centimeters. Now usually when we have a problem like this, we are looking for the perimeter, but here we're switching it up a little bit. We're being given the perimeter, which is 42 centimeters. So in place of the P, we're going to put 42 centimeters. And what we're going to do is we're going to add up our numbers. We'll add our integers so that we can simplify and be working with fewer terms. And I'm going to use the associative property of addition. I'm going to combine the 12 and the 8. That makes 20. And then 7 and 5 are 12. Altogether, there are 32 centimeters plus X centimeters. And again, I know this is something that you can solve in your head. You could do your mental math. And you know that unknown side X has a length of 10 centimeters.